Hello everyone, myself Professor Shantakumari, Head of the Department of Chemistry from E-Content Development Center, Majlis Arts and Science College, Paramannur. Today I would like to discuss gel permeation chromatography or GPC, and this chromatographic technique is somewhat different from the other chromatographic techniques. This chromatographic technique, that is GPC, is also known as size exclusion chromatography, gel filtration chromatography and molecular exclusion chromatography. The learning outcomes are the students will be able to differentiate GPC from the other chromatographic techniques. The students will be able to interpret the GPC data. The student will be able to compute the average molecular weight and the molecular weight distribution of a polymer sample from GPC data. Now, we will see what is GPC. This is a method for separating a given sample into fractions according to their molecular weight. Now, this is applied mainly for polymer solutions because a polymer will be having molecules with different size and different molecular weight. So, molecular weight distribution studies and the average molecular weight determination is important in the case of polymers. Then, what is a gel? A gel is a spherical bead which is made up of glass or a polymer, and these beads are used to fill the chromatographic column. And the speciality of these beads is that the beads are hard and incompressible, and they will be containing numerous micropores of uniform size. This is a diagrammatic representation of a gel. It is a spherical bead with numerous micropores. Now, we will go to the stationary phase and the mobile phase. Now, for every chromatographic technique there will be a stationary phase and a mobile phase, and for GPC also there is a stationary phase and a mobile phase. Now, once you fill the chromatographic column with the beads which contains micropores, and then the solvent is filled, then the solvent will be occupying both the pores and the voids. The pore volume means the volume within the pores, and the void volume is the space in between the beads. And the pore volume, that is a solvent contained in the pore volume, is known as stationary phase, and the solvent in the void volume is known as the mobile phase. Now, this is also a diagrammatic representation, and it shows the pore volume and the void volume. The volume within the pores is known as the pore volume, and the volume in between the spheres is known as the void volume. Pore volume is the stationary phase and void volume is the mobile phase. Now, the principle of a GPC is that a polymer solution contains molecules of many size, large, intermediate and small, and these polymers separate according to their size. That is the difference between GPC and other chromatographic techniques. In other chromatographic techniques we have molecular interaction as the basis for the separation, and it is here the size. So, that is why it is known as size exclusion chromatography. The size depends upon the molecular weight. So, when a polymer solution is injected into the column, the small molecules will be entering the pores while the larger molecules are excluded. The intermediate size molecules are partially trapped. This is an image I have taken from the Google. This is the bead with the pores on the surface, and you can see that the small molecule, smallest molecule, that is a red ball, will be entering the pores and it is trapped inside the pores. The blue ball, which is larger in size, is excluded. The green ball, which is intermediate in size, is partially trapped. So, that is what happens when a chromatographic column is filled with the polymer solution. Then in GPC we have already seen the large molecules are excluded, they remain in the void volume. So, when we elute the chromatographic column or when we wash the chromatographic column with a solvent, the large molecules will be coming out first. So, when we take 2 ml or 3 ml, that is the volume eluted, that will be containing the largest molecules. Then on next washing, the void will be having less concentration and the pore will be having more concentration. So, there is a concentration gradient, and this concentration gradient will drive the smaller molecules or the intermediate molecules to the void. So, in the next eluted volume will be having the intermediate molecules, and the smallest molecules will be retained within the pores for a longer time, and they will be eluted only in the last washing. The small molecules are retained for the maximum time and they will be eluted last. So, this is also an image I have taken from the Google. So, you can see the molecules when we have injected the sample, and on elution they are moving forward and the large molecules are coming out first. This beaker will be the first eluted volume that will be containing the largest molecules, then the next size and the smaller molecules. So, for each eluted volume will be having a separation according to their molecular size or molecular weight. Now, how do we compute the molecular weight, or how do we determine the average molecular weight in the case of a polymer, and also for molecular weight determination? So, for this first we have to take some standard samples with a non-molecular weight. So, we will take the GPC or gel permeation chromatogram of the standard samples, and we determine the eluted volume, that is the volume required for the elution of the samples, VE, for all these molecules, all these samples. So, we will be having a relationship between VE and a molecular weight, that is for each molecular weight we will be having a particular VE, and this graph shows that is M1 is the molecular weight and that sample require VE1 as the elution volume. M2 is another molecular weight, the second standard sample, and VE2 is the elution volume, M3, VE3, and we have if M1 is greater than M2 greater than M3, then VE1 will be smaller than VE2 less than VE3. So, this is a relationship between molecular weight and elution volume we have determined for the standard samples. Now, for the unknown sample, we have the apparatus, GPC apparatus containing two columns, two chromatographic columns are there, sample column for injecting the sample, and we have a reference column also. The solvent is pumped into the sample column and the reference column. Sample is injected into the sample column and both are washed or eluted and will be collecting different elution volumes. Now, before eluting them or before collecting them, the solutions are passing through a differential refractometer. Refractive index detector is shown there, this one, and here we get the difference in the refractive index between the sample and the reference, and that will give the concentration of the polymer solution we have eluted, and this is there is a recorder also for recording the chromatogram. So, here we have a sample column, a reference column and a refractive index detector. Now, small volumes are eluted and we get the record output from the refractive index detector. Record output represents the concentration of the sample. So, now we have a relationship between VE and concentration. Earlier in the from the standard samples we have a relationship between VE and molecular weight. From this graph we have a relationship between VE and molecular weight, and here we have a relationship between VE and concentration. Now, we are plotting a graph between VE and concentration, and then we will be getting the molecular weight distribution graph. You can see that small molecules will be having low concentration. Similarly, the large molecules are also very few in number. The intermediate molecules will be larger in number. So, this is the molecular weight determination. On the y axis we have taken C, that is the record output from the refractometer, and here we have taken the VE, that is small elution volumes each time we have taken collected. Now, for calculating the average molecular weight, number average and weight average molecular weight, we have Mn bar and Mw bar. From the record output we have got H. H means the height of the curve, height of the graph, that is C. And the molecular weight corresponding to that we will be having from the relationship between VE and M. And for each H, or the height of the line, represents the concentration, and concentration is equal to N1 into M1. N1 is the number of molecules of that particular sample, and M1 is the molecular weight of that particular sample. So, H2 is equal to N2 M2, like that we have Ni Mi is equal to Hi. So, from that we can calculate N1, the number of molecules of each fraction. Ni is equal to Hi by Mi. Now, the number average molecular weight Mn bar is equal to, we know the relationship, sigma Ni Mi by sigma Ni, and that is equal to sigma Hi by sigma Hi by Mi. So, Hi we know from the distribution graph, we know the height of the line for each fraction. So, that is taken, computed. Then Mi we know from the relationship between VE and M. Then weight average molecular weight Mw bar is equal to sigma Ni Mi square by sigma Ni Mi, and that can be written as sigma Hi Mi by sigma Hi. So, we can calculate number average molecular weight and weight average molecular weight from GPC data. So, the applications are widely applied in many fields. I will cite a few applications: the separation of proteins from polypeptides and amino acids, the detection and estimation of amino acids in protein analysis. Then just as we have seen, the rapid determination of molecular weight distribution and average molecular weight, the number average and the weight average molecular weight of natural and synthetic polymers. Thank you. I hope you have understood what is GPC, gel permeation chromatography, how it is different from the other chromatography techniques, like we have column chromatography, paper chromatography and all that, where we are where they are mainly based on the interaction between the molecules. Here it is purely according to their molecular size or molecular weight. So, gel permeation chromatography is something different, and this chromatography is mainly applied for the polymer solutions, and I hope you have understood the difference between GPC and other chromatographic techniques, how to interpret the GPC data, how to compute the molecular weight, number average and weight average molecular weight, and also how to represent the molecular weight distribution in a polymer sample. Thank you.